This is fundamental problem 11 from chapter 18. The 30 kilogram rod is released from rest when theta is equal to 45 degrees. Determine the angular velocity of the rod when theta is equal to 0 degrees. The spring is unstretched when theta is equal to 45 degrees. So initially the spring is unstretched, but we still want to find the length of the spring because we're going to need to use that later. So if the length of the rod is 1.5, then the length of the spring initially, since this angle is 45 degrees, is 1.5 times cosine of 45 degrees. And I have my equation here, which is equation 1818, but written a little bit differently. So remember, the potential that we have here is gravitational potential energy plus elastic potential energy. So it's initial kinetic energy plus elastic potential energy and gravitational potential energy plus the work done by non-conservative forces, which in this problem is equal to 0. And then we have final kinetic energy, and then we have final elastic and gravitational potential energy. So we need to figure out the values for everything in our equation here. And the rod is released from rest, so T1 is equal to 0. And the spring is initially unstretched, so the initial elastic potential energy is equal to 0. And then we can always say the initial gravitational potential energy is equal to 0. So let's just do that, which means the final gravitational potential energy is going to be negative. Then we have to find T2. And for that, I can use equation 18:7, and I want the moment of inertia about the instantaneous center of zero velocity. Okay, so we need to find the instantaneous center of zero velocity. In order to find the instantaneous center of zero velocity, consider what would happen if roller A continues to move downwards. So before we got to this point, roller B was moving to the left. But if roller A continues to move down, then after this point here, roller B would start to move this way. So this would be the turning point here in the instantaneous center of zero velocity. This was what was happening before. So roller B is not moving to the left anymore. Right at this moment, the velocity of roller B is 0. So if that's the instantaneous center of zero velocity, then I need the moment of inertia about one end of the rod. So I take a quick look on the back cover of the book and find that the moment of inertia about one end of the rod is 1/3 times the mass times the length of the rod squared. So for the kinetic energy, we will have 1/2 times the moment of inertia about the instantaneous center, which is 1/3 times the mass of the rod times the length of the rod squared times the angular velocity. And what are we looking for in this problem? We are looking for the angular velocity. So we're trying to find the angular velocity when the angle is 0 degrees. And this is equal to 11.25 times omega squared. Then we need the final elastic potential energy. And elastic potential energy is 1/2 times K times S squared. S is equal to 300, so we have 1/2 times 300 times S, which is the current length of the spring, which is 1.5, minus the rest length of the spring, which is 1.5 times cosine of 45 degrees. And that's squared. And this is 28.95. Then I need final gravitational potential energy, which is going to be negative since I said initial gravitational potential energy was 0. So for the height, I use the mass center. So that's my datum there. So I want this height. It's going to be negative because of the way I did this. So this distance from here to here is half of 1.5, which is 0.75. So this distance here is 0.75 times sine of 45 degrees. Probably it would have made more sense in this problem to say the final gravitational potential energy was equal to 0, and then you'd be looking for the distance over here, but it doesn't really matter. And for gravitational potential energy, I have the mass, which is 30 times 9.81, now times the height, which is 0.75 times sine of 45 degrees, and I already have my negative sign there. And this gives me 156.1. Okay, I think I have everything I need now. I can use this equation, plug everything in initially. I just get 0 on the left-hand side, and finally I have 11.25 times omega squared. This elastic potential energy is 28.95, and then final gravitational potential energy is negative 156.1. Then to solve for omega, bring these two terms over to the other side. That's 156.1 minus 28.95. Divide by the 11.25. Take the square root, and you get 3.36 radians per second. And that concludes Chapter 18.